Concrete encasing of lightning ground rods is sometimes done in areas with high resistivity soil to improve the rod's grounding. There are concerns about the potential for the concrete to explode if lightning strikes. When lightning strikes, a large current flows through the ground rod and into the surrounding soil. If this current meets high resistance soil, it can generate significant heat. If the concrete encasing is too thick or has low moisture, it can act as an insulator, preventing heat from escaping. This can cause pressure to build up inside the concrete, potentially causing an explosion. The National Electrical Code, or NEC, doesn't specifically address concrete encased lightning ground rods, but it does offer guidance for concrete encased grounding electrodes for electrical systems. Article 250.50. A5 requires the concrete to be at least 19 mm, or 3/4 of an inch, thick for non-metallic electrodes and at least 50 mm, or 2 inches, thick for metallic electrodes. Article 250.56. A9 states that the concrete mix should have a minimum 28-day compressive strength of 21 megapascals, or 3,000 pounds per square inch, and a 10-day resistivity of not more than 50 ohm centimeters. To reduce the risk of concrete explosion from a lightning strike, several practices are recommended. Firstly, use a thin layer of concrete, 19 mm or less, around the ground rod. Secondly, make sure the concrete mix has a high moisture content to help heat escape. Thirdly, avoid using high-strength concrete or concrete with low permeability. Fourthly, install multiple ground rods spaced apart to provide redundancy. In addition to the NEC requirements, it's important to consider other factors when using concrete encased lightning ground rods. Local building codes may have specific rules about concrete encasing of ground rods. The resistivity of the soil needs careful evaluation to determine the correct grounding method. Concrete can reduce the corrosion resistance of the ground rods, so regular inspections and maintenance are essential to ensure it remains effective. Ultimately, for grounding lightning protection systems at high resistivity soil, it's best to consult with a qualified electrician or lightning protection professional. They can design and install a system that is both safe and effective.